Welcome. In this explainer, we're going to put on our detective hats and investigate a really fascinating medical mystery called myasthenia gravis. We're going to follow a trail of clues, starting with the symptoms you can see, all the way down to the microscopic level, to figure out exactly what's causing this puzzling condition.
But hey, before we start digging into the evidence, let's kick things off with a big question that's going to guide our whole investigation. What happens when your body's own defenders, your immune system, get confused and actually start to attack you? Just keep that thought in the back of your mind as we start to piece all this together.
So, here's our roadmap for this investigation. First, we'll define the mystery. Then, we'll check out the symptoms, kind of like taking the victim's statement. After that, we'll zoom way in on the microscopic crime scene, identify our culprit, and finally, connect all the clues to close the case.
All right, let's get this investigation started. Every good mystery starts with a name. So first things first, we need to understand what exactly we're trying to solve here.
Okay, so the condition is called myasthenia gravis. And what's really cool is that there's a huge clue hidden right there in the name. It's a mix of Greek and Latin that literally translates to severe muscle weakness. So that's our first and probably most important piece of evidence. This whole mystery is about the muscles.
Let's move on to our next step. Every detective has to look at the evidence, right? For us, that means we're going to observe the common symptoms. It's like we're taking a witness statement to really get what's going wrong.
So, as you can see, a lot of the time the symptoms start around the eyes with things like droopy eyelids or double vision. But it can also affect how you speak, swallow, and even how you walk. A clear pattern is definitely starting to show up. This weakness is targeting the voluntary muscles, the ones we use for all those precise movements.
Okay, so now we've got the what. We can see the symptoms. But the real mystery, the million-dollar question, is why? Why is this muscle weakness even happening? To get that answer, we've got to grab our magnifying glass and zoom way, way in to check out the crime scene at a microscopic level.
All right, our investigation is taking us to a super specific spot, the neuromuscular junction. Now, I know that sounds complicated, but it's really just the critical communication point where your nerves talk to your muscles. This is our crime scene. This is where the breakdown is happening.
Now, to understand this crime scene, we've got to meet the key players. And player number one is the chemical messenger called acetylcholine. The easiest way to think about it is like a little text message that gets sent from a nerve to a muscle. And its one and only job is to deliver the command, contract.
Of course, for that text message to be received, the muscle cell needs a mailbox, right? Well, that's the acetylcholine receptor. It's like a dedicated docking station on the muscle. So if acetylcholine is the key, then the receptor, well, that's the lock it's made to fit. So this is how it's supposed to work. A nerve signal shows up, the messenger, acetylcholine, gets released, it latches onto the receptors on the muscle, and boom, you get a strong, healthy muscle contraction. It's a perfect, totally seamless process, or at least it should be.
And now, it's time for the big reveal. We've just seen the normal process. Next, we're going to put it side by side with what happens in myasthenia gravis. By looking at the differences between these two, we're finally going to identify our culprit. And here it is, the smoking gun. The evidence points to these rogue proteins called acetylcholine receptor antibodies. But here's the twist. These antibodies are being made by the person's own immune system. These are the intruders at our crime scene. It's a classic case of friendly fire.
This comparison really tells the whole story. Over on the left, you see the normal process. The message gets sent, and it has plenty of spots to land. But on the right, in myasthenia gravis, those rogue antibodies have latched onto the receptors, and they're physically blocking them. The message is still being sent, but it just can't get through.
Here's probably the best way to picture it. Imagine the receptors are parking spots, and the acetylcholine molecules are cars trying to park. Well, in myasthenia gravis, the antibodies are like traffic cones that are blocking most of the spots. The cars are there, they're circling the lot, but they have nowhere to park. So the weakness isn't because there's a lack of cars, it's because there's a lack of open parking spots.
Okay, let's bring this all together. In this last section, we're going to connect this tiny, microscopic evidence directly back to those real-world symptoms we saw at the very beginning. It is time to officially close this case.
So how exactly do these blocked receptors lead to something like a droopy eyelid? Well, it's a pretty direct chain of events. First, the antibodies block the receptors. Second, that acetylcholine message can't be fully received. Third, the muscle cells don't get a strong enough signal to contract like they should. And the final result is that severe muscle weakness that gives this condition its name.
And there we have it. The mystery is solved. Myasthenia gravis is what we call an autoimmune disease. It's a textbook case of friendly fire, where the body's own defense system gets confused and mistakenly attacks itself, blocking those absolutely critical communication points between our nerves and our muscles.
And this brings us right back to that question we started with. But now we have a totally new perspective. The immune system is just this incredibly complex and powerful protector. But what does it really tell us about our own biology when that very system, designed for our survival, becomes the source of the problem? It's just a fascinating reminder of the delicate balance that's required to keep our bodies running. Thanks for joining me on this investigation.